Created by IBM in 1987 for their PS2 line of computers, the VGA standard quickly became the minimum video standard adopted by, well, pretty much everyone. Your fancy 50 series video card that cost more than my first car still pretends to be one, unless it's set on fire. Designed by boring people in suits to go inside boring business computers, the VGA card was only really intended to offer a bunch of colours and a higher resolution than the vomit-coloured CGA and 16-colour EGA that came out before it. I think you were supposed to at most run Windows 3.1 on it and play Solitaire. However, maybe the boring people in suits weren't as boring as we thought. Instead of making a card out of discrete logic, it features a bunch of registers that can control some fairly fundamental parts of the card. Like, the card isn't programmable like a modern GPU, but it's got enough complicated stuff inside it that we can kind of fiddle with how it works and make it do things it wasn't discretely and deliberately programmed to do. It's kind of a thing we can take advantage of, and it's really, really cool. Things that we can do are like mess with the horizontal and vertical screen timings. And since at the time RAM was expensive and slow, it had planar memory because it made sense to put different red, green and blue values into different physical memory chips. You could then pull all three colours out into several special latch registers and dump that on the screen far quicker than any RAM could cope by itself. Like we saw last week, it also supported 256 colours on a screen that had 320 by 200 resolution. Well, it turns out that if you sort of enable that 320 by 200 mode, but then fiddle directly with the VGA card's registers, you can create a different 256 colour screen resolution that is unofficially known as Mode X. This is a video mode not actually designed into the card. It's just what kind of happens when different parts of the card are switched on at the same time in a weird combination. Somehow the whole thing just kind of goes, well, alright, I'll give you a video signal. If you can decode it, good luck to you. So let's have a look at what this is, because it's weird, undocumented, and kind of cool. Several of you, in my last video, pointed out that I needed to go and read the Graphics Programming Black Book, and you were right. So I abused my print credits at work and printed some of it out, specifically the bits to do with Mode X. Let's have a look. So this is the Graphics Programming Black Book by Michael Abresh. You can get it on this website here, so fatcode.net. And you can get a PDF version, or you can view a HTML one. However, an actual better place to go is this GitHub repository here. So, okay, this one. Because inside it, in the source directory, it's all written out as Markdown, and you can just see it, and there it all is. Also, if you go back and you go into one of these other folders, I think it's got the code listings. Actually, no, that's the thing with this. The code listings are part of the book, so if you go in here, you can find the code listing, and you can copy and paste this. If you go on this version, you can download the book's source code, but it's not always correct, like it has the wrong file name. Like, you'll find a file called this, but it might not contain this file and this data, it might contain something else. So I think someone copied it and then didn't check that the files contain what they should do. But either way, here's the book. So I think originally this book just was put on a CD, and then people have ripped the CD contents and put it in a website, because here it is now on gamedev.net. But whatever, you can read it, and there's lots of stuff. Some of it seems a little bit irrelevant for what I'm doing at the moment, but I'm sure later on I'll find some of this highly relevant. But the bit that's useful is down here, around chapter 40 odd. So each chapter is well written. It's not just some terse set of text files that's been turned into a book. It's actually got an explanation that explains how this thing works. And it also includes a lot of source code. In fact, this is what I've been using. So look, here is the source code on how to put your PC into Mode X. So you need these things, you need this stuff, and then it goes through and it tells you step by step what it's doing. I don't understand what any of this stuff is. I'm sure later I'll figure it out, but for now, I'm just typing this out and compiling it. But it's all here. And conveniently, it's all written for Boolean C++, which is what I'm using. So if I'd used DJGPP, none of this would have worked, and I would have wasted weeks trying to figure out how to convert a small model DOS piece of code into something that runs in protected mode, and probably gone mad and given up. So this is nice and easy, because as we're going to discover, Mode X is weird. All this low-level stuff is exactly what I want to play with. When I saw demos on my PC, I always figured there must be some secret way to make all the hardware do clever things that I was seeing. All the programming books I ever read, at best, taught you that video memory was just a giant array and you put bytes into it. It was like when I was learning SDL and things like that, there was mention that there was video hardware somewhere inside the machine, but all you had was this surface thing that you drew into. And I couldn't quite figure out why I couldn't create things that I saw in demos. I figured there must be something special that I was missing, and it turns out I am. So what I did was I scraped together all the test programs that you get throughout these first set of chapters, and I kind of ran them. So there's a right pixel test that all it actually does is draws a line across the screen, and that's it. But then there's another one, which looks a bit nicer. There we go, this draws a colour palette, which is really actually quite handy because I don't know what any of the colours are, and now I've got a little list of them. And I can sit and painfully get my mouse and I can count like 0, 1, 2, 3, 4. So if I need a colour, I can count across this thing and figure out which colour is which. Something I really don't understand is how this patterned fill thing works. It's explained in the book, but I don't quite get it, but the patterns are really quite nice. Like, this one looks quite cool. They're not just the same repeated checkerboard pattern, which I figured they would be. I don't quite understand how they repeat or how this pattern appears. Like, the code for it is just up here. This is the patterns. It's like repeating colours, but I don't understand how you make a little sort of 3-step box pattern from just writing this. I don't know how you define the 3 boxes. It's like something I need to play around with more and figure out. But this is what writing the code is like. It's fairly, I'm going to say straightforward because all the nasty assembly is hidden out the way, but it still requires quite a lot of thought to make this work. So as you can see from following this book, it's all written in assembly language because it's the quickest way of doing what we're trying to do. Trying to write this in C would be possible, but would still turn into this assembly, so you may as well just write it like this. But that does bring up one small problem with things that I know. I know C, I'm quite good at writing in it. Assembly, especially x86 assembly, is not something I've done before. However, as we've seen from the code, if you kick the card in its registers, it'll do some pretty odd things. Odd things we can exploit to draw graphics better, in ways IBM never intended. Our boring business machine can do less boring things. One minor problem, all this voodoo is done using assembly. You could do it in C, but nobody does. This is a nice example of where writing code in assembly is really relevant. Now, I can't read assembly that well. I can kind of get by slightly in Z80, but x86, I don't really know it, so I sort of just have to accept that these routines are what we do, and then I'll move on to using them. I'm sure later I'll dig into x86 assembly and actually understand what's going on, but for now, we'll just use the functions and worry about where it's going in the bowels of machines some other time. We're after some pretty graphics at the moment. Let's make nice stuff appear on the screen. One of the nice things in this book is that there's an animation demo. It's not just drawing rectangles on the screen and then it's up to you to figure out what to do next. A lot of these things that I've found often like stop when it gets to the good bit. Almost like the person who's written the instructions can't work out the next bit, so they've just stopped. So, you know, I was half expecting to get some information on how to open mode to X, draw some patterns, and then that'd be it. But here are some more things that are really useful. Like you can copy from system memory to the screen with a mask. So you can upload little pictures to the graphics card and draw them all over the screen. Again, it's all written in assembly. Pages of the stuff. There's something weird with copying where you have to make different image alignments because you're copying in groups of 4 pixels. So here's an algorithm that does that. Well, here we go, animation. And I was kind of curious what this was going to look like. You've just seen it running, so let's have a look in the book, and then I'll show you the code on my actual, well, my simulated actual computer. So here is the animated Mode X screen demo. Look at this, it's a nice black and white. It's clearly like a photocopied picture or something. You can see the grain in the paper and everything. That's probably the scanning process of this book, but I don't imagine the original looked any better. So I saw this and I wanted to make it work because, you know, look at it. It must do something a bit more interesting than just draw static images on the screen. I wanted to see this working to see how good it was. Fortunately, here's all the source code. Now, it's one thing seeing source code in a book, so let's go look at source code on an actual computer. I'll rerun the program just to remind you what this does. So there you go. As you can see, it's got a background, and then it's got things that move over the front of it, kind of just bouncing around the screen. So there's a few things here that are worth kind of trying to figure out. Like, how are the things moving around the screen? What draws them? What is making sure that they don't smear the background and act strange? And then how have we drawn some of these shapes? Like the sun is round, and there's these triangle things and trees. So let's go look at the code. Starts off at the top with a bunch of hash defines, and then we get into some patterns. So there's a pattern for a pine tree, pattern for a brick, and then a pattern for a roof. The next part of the graphics, and if you've ever done any graphics editing, you'll kind of see where this is going. So these are the pixels with colours. So each number is a colour. And then this is the mask, and if you kind of squint your eyes and look at this, you can kind of see that it's making out a circular shape. Same for those moving things, which are kites, and if you kind of squint your eyes, that looks vaguely sort of kite shaped, I guess. It's a bit easier to look at if you see this one. And then we've got a big array of these animated objects structures, which contains the basic stuff that you'd need for moving something around the screen. So if I'm making a game or something, I can steal this and reuse it. It's great. But here's a list of all the items that are going to move around the screen and their positions. That's that create masked, align masked image function from before. And now here's the actual main piece of code. So the first thing it does is it gets the kite image out of kind of the binary that's just been loaded into RAM, and it puts it inside video memory at a certain position. So the first thing it has to do is allocate some memory in RAM to copy the data into, so it can then turn it into whatever a aligned masked image is, and then it puts that into video RAM. It then draws the background, which draws pretty much everything. We'll see that in a minute. And then it's doing page flipping, so we've got a front screen and a back screen. So it's copying it to both screens. So we've got a page 0 and a page 1. Then it's a sort of basic game loop, really. We've got an endless loop that flips the page, removes the items by just copying the background over the top of them. So in video memory, you can imagine that you've got the front page, the back page, and then a separate page of video memory that just contains the background. So we're not doing any clever removal of background stuff or dirty rectangles or anything. We're just copying the background back over where the image was. Then we're moving and drawing the images that move. And then we're just flipping the page. So it's the same basic sort of game loop that's in every game, really. And then we quit and go back to text mode. Draw background seems fairly sane. We're filling in a rectangle, and then we're drawing a pattern to create the ground. So the cyan is the sky, green and brown rectangle for the ground, blue water at the bottom is another rectangle. The mountain, oh, alright, I see how this is working. So we're drawing rectangles. We're drawing 120 rectangles, and each time they get a little bit either wider or smaller, depending which way they draw this, for either bottom up or top down. So it's not drawing a triangle, it's just drawing rectangles that are filled in. The sun is the same thing. There's a bit of dodgy math going on here that must draw rectangles that sort of describe a circular shape. These are some of the mad kind of low-level crap that you do in graphics when you're trying to draw things, because computers don't know what triangles are, apart from modern ones which totally don't know anything but triangles, but this is DOS. All it knows is drawing pixels on a screen, and drawing boxes is easiest. The trees again are just going to be a bunch of triangles. Same with the house, triangles with a box underneath it. And then the smoke is just the little masked smoke sprite drawn up the screen. So here's some fairly basic kind of standard pretend physics to bounce an object around the screen, you know, like the DVD screensaver thing. That's all this is doing. It's got an X and Y position. You add in a velocity vector to it. If you're at the edge of the screen, you just invert the vector and it goes the other way, and that's all it does. So the code is not that like weird. There's no strange special DOS stuff in it. We're just making use of all the tools that do all the strange DOS stuff that's written in assembly. Now this is nice and all, you know, it's kind of nicely bouncing around the screen, but it looks a little bit manic and it's just sort of random. I wanted to do something else. I wanted to try and like understand the code a bit more. I'd typed out a lot of it, and then I'd copy and pasted the rest. I'd run it and gone, oh, it doesn't crash. This is really nice. I'm now going to do the next thing, which is improve this or do something different. That thing I tell my kids in lessons, you've made it work, now play around with it and figure out what else you can do. So let's go see what I managed to do. Now that I've got the basics of ModeX animation working, I want to own this code a little bit more. It's all been, well, I've not really typed it out, I've literally copy and pasted it out of that GitHub repo, and I made it work. So now I want to change it. I want to do something that makes it a little bit more my own program. I'm going to try and animate the smoke coming out the chimney. Now, I figure that I can probably just use a lot of existing code as a bit of a structure to go off. So I'm going to make another array of these animated objects, and I'm going to stick in a smoke particle instead. So while trying to type out a new entry for the struct, I couldn't quite figure out what this X other page and Y other page parameters were. So while I figure that out, I've gone off to do some other coding instead. What I'm doing here is reusing this create masked aligned image function for the kite and just then replacing it all to be the smoke. This is what copies various versions of the image into video memory to be used later on. So I need this definitely for the smoke particles. And while doing that, I've kind of figured out what this X other page and Y other page value should be. I don't quite know what it's for, but I just know it should be the same as the X and Y, so we'll just copy and paste that and make it the same thing. If I now put 4 of those into the array, what I want to see is if I've broken the code or not. So what I'll do is I'll comment out drawing the smoke as it is currently, and if I run it, there shouldn't be any smoke on the screen. And as you can see, this is still working and there's no smoke. So now we just need to put this smoke that I've created on the screen and make it move. I like to break my programs down into small pieces to make it easier to debug. So what I've done is just put the 4 pieces of smoke back on the screen at their current location, but using my new code just to check everything still works. To actually move the smoke, I need a function that just adjusts the X and Y positions, and I'm just copying and pasting the kite one and then just making it change the Y position and reset it when it goes off the top of the screen. You can see there's a bit of an issue with drawing the smoke. It doesn't remove it when it's moved, so it just looks like it's smearing, but we can fix that. That's not that difficult to do. All I need to do is take the code that cleans up the kite and just make it change it to be the smoke, and I can use search and replace to save myself a lot of effort and repeated typing. The end result is the same thing as before, but now the smoke's coming out the chimney. I know it's coming in little groups of 4, but this is good enough for me. We're now going to try and do something different. I've tidied up the code a little bit. I've made it only have 3 kites that now gently float across the top of the screen. I'm trying to build a little scene. I figure it'd be quite nice, since there's some water at the bottom, to have a duck that swims across the bottom of the screen. Because then I've also practiced trying to create a new sprite from nothing and work out how to do that as well. I don't have a sprite editor, so I think what I'm going to need to do is find some sort of pixel art picture of a duck and then manually type in the colour codes to draw the pixels by hand. Drawing the sprite is pretty easy. I just went on Google, had a look for a pixel art picture of a duck, and then brought up the colour map for 256 color mode VGA, and then literally counted how many pixels across and down the duck shape is and which colours to type in, and then just tediously typed it all out. It didn't take that long, but if I was doing this properly, I'd definitely use some sort of sprite editor and load pictures off disk. There's no way you'd type this out for an entire game, But this is not an entire game, this is just me having a bit of fun with some code. Now at this point I'm about to make a really hideous mistake. See if you can spot it. It's all to do with how I use copy and paste, which I consistently press the wrong keys for. You see, what I'm trying to do now is make a mask for the pixels of the duck that are not transparent, so that there's a transparent background and it's not just floating in a white box. If you've not spotted the mistake, you'll discover it in a minute. I did. Just like the smoke, we now need to put the duck into video RAM, so I'm just literally copying and pasting the same piece of code to do that. And then this is where we hit upon a little problem, because when I run it and compile it, it complains it doesn't know what duck pixels is. So let's just go look inside the code and figure out why it's doing that, because I literally typed that out a couple of minutes ago. It took a long time, I remember typing it. And yeah, so I'd clearly just copy and pasted over the exact same code and then renamed it. Fortunately, search and replace is quite easy to do, and it fixes the problem very quickly. So when I ran it, I was expecting nothing much to happen. What you didn't see is I put a duck in as one of the items of smoke, so that was expected. There should be a duck coming out the chimney. What I wasn't expecting is the weird smeariness that's happening, and just that the sprites all look a little bit broken. This was quickly fixed by me remembering how to actually write code, and remembering that you need to add on 2 things to the last one, because there's 2 images before it. Sometimes the most simple mistakes cause the biggest problems. And there we go. We've got a duck coming out the chimney, which is not where the duck is supposed to be, but it proves I've managed to draw the thing on the screen and actually type it in from a piece of code. So we're winning. Let's keep going. Now sometimes when you're coding you can get stuck repeating patterns that work without actually thinking whether you even need to do it in the first place. I was going to make another array of ducks, but then I realised that they move in the same way as a kite, so they can just go in with the kites and just be called ducks, and it'll all work together and I don't have to do any more coding. Then when I compile and run the code, it works, and we've got a little duck going across the bottom of the screen. I know it should probably turn around and go the other way, but I'm not putting that much effort into this thing. I'm literally just having fun. I then sort of faff around trying to find decent colours to make the water look nicer, trying to understand how this pattern thing works. I still don't get it, but I've now made the water look a bit more watery than it was before. But I'm quite happy with this. This looks quite cool. And there we go. I've taken a piece of code that I've never seen before, fiddled around with it, added my own things to it, and generally I now understand a little bit more about what's going on with ModeX. This is quite cool. I really enjoy this kind of programming where I'm not trying to make a perfect working system. I'm literally just hacking around and figuring things out as I go. I've now just been changing the background colour to make the sky look a bit less bright cyan like a ZX Spectrum. I think that'll do for now. I've learnt enough from this little program. I've got a bit more familiarity with ModeX and how to draw things on the screen. I've got a bunch of nice assembly routines. Slightly more deeper though, I now know how to combine C and assembly together in Bol and C++, which I'm sure will be a very useful thing in the future. Thanks so much for watching and making it all the way to the end. If you want the code for this video, you can find it on my GitHub repo, which is linked below. I'm trying to make more regular content too. It's my aim to try and do a video every 2 weeks or so, maybe a DOS video one week, then an Agon Lite video after that. So stick around and see if I can do this experiment or not. Poking around in DOS has got me interested in other ancient operating systems and low-level stuff that I can't do on modern machines. Like maybe there's OS2 development I could have a go at. And I recently bought a second-hand Wii, and it lasted about 10 minutes before I'd stuck the Homebrew channel on it. At some point I want to get DevKit Pro and have a go at Wii development, see what I can make that thing do. I quite like the programming stuff if you'd not noticed. I also like making detailed videos like this, but I also have to play that stupid YouTube game and create videos that do well so that the YouTube gods shower me with views, because otherwise no one actually gets to see the video no matter how good it is. The thing is, I don't always want to make videos that please the algorithm. So if you'd like to support my work and get access to some early or extra video releases, check out my Patreon, which I've linked below. I'm just getting started, but in addition to getting an ad-free version of the video earlier than it appears on YouTube, you'll better see previews of future videos while I make them. I'll kind of turn my camera on whilst I'm doing stuff, and you get other random behind the scenes things. If Patreon isn't your thing, it's totally fine, nothing's changing here, I'll always just put videos on YouTube. And if you feel like making a one-off donation, I've got a Ko-fi link in the description too. Do you remember when YouTube descriptions used to actually contain like explanations of the video and not just links and people asking for money all the time? It's that YouTube game that we've got to play, you know. If you like reading, have a look at my website, which is also linked below. I like to post written versions of videos that I make and also do a bit of good old-fashioned blogging. Sometimes what I do isn't really worth a video, so I'll just stick like a written description on my website instead. Either way, I appreciate you being here, and I'll see you in the next video.